It started as a well-designed, purpose-built flying boat bomber. Most of the first batch of almost 200 went to the United States Navy. When the first production models appeared in 1936, it could have been supposed that only a few hundred would ever be produced. But world events took a sudden turn, and in 1939, as soon as the war in Europe began, the British ordered large numbers of the Mark V. The United States Navy ordered an extra 200 to patrol what were then its neutral waters. Not only did delivery of the first Royal Air Force PBYs signal the start of a long and fruitful relationship with the model, the RAF also gave the PBY its name, the Catalina. It stuck to be adopted almost universally. One of the early tasks for the young factory was to prepare plans for the Navy's new flying boat. It was another first for San Diego. In the world of biplane flying boats, it was a monoplane. It was called the PBY. During the Depression, contracts were scarce and competition was tough. The move was a big risk for Consolidated. It was a time when plane making was still the domain of the craftsman. Critical eyes and skilled hands, marks of a man who had learned his trade, were very much a part of aircraft manufacturing. This is the main wing assembly area, where two technologies, sophisticated steel framework and old-world hand-stitching, brought canvas and metal together to form the massive PBY wing. This wing was the key to the success of the PBY design. Not only would it provide great lift, but it carried the entire fuel load, giving the PBY its legendary range capability. In the center of the wing, you can see the two portholes that provided access to the main fuel tanks. A partly finished main spar is transported to the next stage of construction. In the fabric department, a special quality unbleached cotton is secured to the wing with knotted stitches that cannot come untied. The use of fabric and metal provided a combination of lightness and strength. The process that achieved that combination consumed hundreds of hours of exacting craftsmanship. The final process in covering the wing was the coating of special aviation dope, a resilient lacquer that stretched the canvas taut and bonded the components together. Extra reinforcing was glued over each rib. The PBY's all-metal hull needed tens of thousands of rivets. Consolidated's rivet machine would produce over 1 million punched out of mild steel every week. Given the extra stresses placed on flying boats with the battering of their large hulls on every landing, seams had to be stronger than usual. So the millions of rivets coming out of the machines were given special treatment. To keep the material at its most workable and provide the tightest fit, each batch was placed in refrigerators and frozen until it was ready for use. Metal ribs and stringers form the shape of a hull that must carry the full weight of each PBY as it lands. The cold rivets must fasten sheet metal to this framework into a skin that remains watertight against the hard buffeting of each return to the water's surface. Wooden wedges ensure the closest fit between framework and skinned, and only when the seal is perfect is the entire hull rotated to its upright position and moved on to the next process. The whole complex jigsaw of thousands of preformed pieces is assembled in a process that demands the finest tolerances before the fuselage takes its final form. The shape that will make the PBY instantly recognizable is beginning to emerge. These craftsmen are, in a sense, as much boat builders as plane makers. Just like a boat, the PBY must float, and no water can be allowed to find its way through the skin. This is the unique center spar, which supports the wing. In an unusual piece of design, it also houses the flight engineer, who sits high above the two pilots, close to the two engines he constantly monitors. At this stage, the clean, shark-like profile of the hull is almost complete. The final test of waterproofing will follow. It would take enormous tanks to immerse the hull. Instead, its integrity is proven simply by filling the inside with water and checking for leaks. Then, it's off to the paint shop to be scraped down clean in preparation for the many coats of a waterproof paint that provides final protection. The paint, which has to survive the wear of marine landings and takeoffs and the corrosive effect of salt water, is applied in carefully controlled conditions. Positive air pressure is maintained by large fans, making sure no dust or other particles find their way in. After painting, the completed fuselages are stored, ready for fitting the main wing spar. These are the early model PBY-3s with their distinctive flat-side canopies. They're part of a pre-war order for 65 aircraft placed by the United States Navy. At this stage, the main wing spar is brought in to be fitted to the small surface of the center column. You can see the thickness of the wing, the center section of which is almost completely occupied by fuel tanks, holding 1,750 gallons. The PBY was powered by two 1,200 horsepower Pratt & Whitney twin Wasp engines. They were secured to the wing with just 4 bolts each. The dry California climate made it possible to install the massive wings out in the open. This simple fact saved thousands of feet of hangar space. A feature of the PBY was its retractable wingtip floats. In flight, these could be raised so they became an extension of the wing, reducing unnecessary drag and improving the plane's handling. The floats were lowered again for landing. Before each plane was handed over to the Navy, it was thoroughly inspected. In most aircraft at the time, the pilot and engineer were stationed close together, but in the PBY they were separated and could only talk to each other by interphone. You can see the engineer's window located in the wing spar at the bottom of the picture.